Hello everyone. This video introduces our recent work named HOISDF, Constraining 3D Hand Object Pose Estimation with Global Signed Distance Fields, which is published in CVPR 2024. This work was carried out by Haojie Qi with Chen Zhao, Matthew Salzman, and Alexander Mathis at EPFL. Please check the project page if you want to know more details. Pose estimation during hand-object interactions from a single monocular view is relevant for many applications. Many excellent 3D hand pose estimation algorithms have been developed. However, due to severe occlusion, they can easily fail during hand-object interactions, such as in the example video. This has led to the emergence of dedicated hand-object interaction datasets, such as DEX-YCB and HO3D. And subsequently, joint hand-object pose estimation has drawn increasing attention. To address the challenge of frequent occlusions, existing methods often rely on intermediate representations to increase performance. They can be roughly classified into two directions: direct lifting and coarse-defined methods. Direct lifting methods first filter 2D image features according to the pixel positions of the hand and object, and then use the remaining features to make predictions. These methods do not utilize explicit 3D intermediate representations and rely entirely on the network to learn the mapping from 2D image to 3D pose. Coarse-defined techniques make an initial 3D prediction from the 2D image and improve upon it with a refinement network. The intermediate representations can either be hand joints or hand vertices, which require both global and local clues and easily get suboptimal results that are hard to refine in the following stages. Thus, existing intermediate representations can be interpreted as explicit shape representations. Although these representations can incorporate 3D shape information, we argue that implicit shape representations in the form of signed distance fields, SDFs, offer more effective 3D shape information for subsequent computations. Why signed distance fields? Firstly, shape information is directly encoded in the model parameters, which yields implicit shape constraints for the whole model during training and inference. Secondly, 3D shape constraints, such as contact, can be directly introduced in the SDF portion of the model without additional refinement. With our novel design, SDF can provide global and dense constraints for hand-object pose estimation. In contrast to direct lifting and coarse-defined methods, which struggle to refine poor initial predictions, the distance field yields global cues not limited to areas near an initial prediction. To effectively take advantage of SDFs, we introduce HOISDF, a hand-object interaction pose estimation network with signed distance fields, which uses SDFs to guide the 3D hand-object pose estimation in a global manner. HOISDF consists of two sequential components: a module learning to predict the signed distance field for the hand and object, and a module that performs pose regression that is field-guided. Specifically, the global signed distance field learning module regresses the hand and object signed distance fields based on the image features. The module is encouraged to focus on capturing global information, for example, rough hand and object shape, global rotation and translation, by regressing signed distances in the original camera space. Since we believe global plausibility is more important in the intermediate stage, while fine-grained details can be recovered in the later stages. After the field learning module, we use the learned fields to predict the hand and object poses. To effectively leverage the dense field information, our field-guided pose regression module effectively uses the learned field information to sample informative query points, augment the image features for those points, gather cross-target cues to reduce the influence of mutual occlusion, and combine the point features together to estimate the hand and object poses. Overall, HOISDF can be trained in an end-to-end manner. We achieve state-of-the-art results on the DEX YCB and HO3DV2 datasets for pose metrics and mesh metrics, outperforming the existing methods by a good margin. Qualitative comparisons with the existing state-of-the-art methods on the DEX YCB and HO3DV2 datasets show that HOISDF effectively uses robust global clues near the hand and object to deal well with various objects and severe occlusions. Furthermore, we did extensive ablation studies to verify the effectiveness of the SDF intermediate representation, as well as all the components in our field-guided pose regression module. Check out the paper to learn more. Finally, we visualize the intermediate query points generated by the learned SDF. The darkness of the query points reflects the predicted distance from the query point to the hand and object surfaces. The intermediate SDF representations can capture the GT3D hand and object shapes. HOISDF effectively uses the robust global clues from SDFs to deal well with various objects and hand movements, as well as their mutual occlusions. We thank you very much for your interest in our work. Please check out our lab website if you want to explore other research